Hey there. I'm going to walk through some of the techniques to use the microscope today and how to get a sample of onion tissue, just so you can see how it's done, since we're not really able to do it in the classroom right now. So first off, when you get a microscope, it's going to look like this usually. It will have a cover, which you will remove. It will have a very nice coiled power cord around it, which I'm hoping it will look this nice and neat after you are done using the microscope as well. And you uncoil it fully, okay? You have to fully unfold it, uncoil it, so that you don't have an electrical cord sitting really close to the light source, which can get kind of hot. So we're gonna plug in. All right, and if you'll see right now, actually the light was already on, look at that. So that's the light source and you can see it right there. I'm gonna turn it off for now while I prepare the sample. So the things you will need to prepare a sample, you will need, this is called a microscope slide, okay? You will also need, I'm gonna curve this down a little bit so you can see what I'm doing, okay? You will also need these, which are called cover slips. And when you open them up, you will see that they are tiny little squares of glass. Okay, these things break very easily, so do handle them very, very carefully. All right, so these are the two things you will need. We are doing an onion sample, and so what I've done is I've cut a little bit of onion here, and honestly at this point what I'm going to do is I'm going to go ahead and put on my safety gear, and it's not just because onions smell bad, but we're going to be using a dye called iodine, which can be a skin irritant. So I'm going to put on my safety equipment to do this. And I have goggles here as well. So once I have everything sort of in place here, then I can pick up this onion a little better and show you. Okay, so you can see how I have all these different layers of onion. And so what I'm going to do is I'm going to peel off here, and using tweezers, I'm going to go on the inside of the onion here, and hopefully I can make this work pretty well for you. And what you hopefully will see is me starting to get some little bits, I don't know if you can see that, of onion tissue. Okay, and I really want a bit that's like even and smooth and doesn't fold in on itself. Ah, there we go. All right, can everyone see that? So I'm going to take that, I'm going to place that on my slide. Hopefully you can see that I placed it directly on the slide. I'm trying to do that without getting any folds, okay? And then I'm going to take iodine, which is my stain, and I'm going to put a couple of drops over the top and bottom of that onion tissue, okay? And then I'm going to take, and hopefully you can see this reasonably well, I'm going to take this cover slip. Remember I said to handle very carefully. I'm going to see if I can pick this up. All right, so I'm going to take this. I'm going to go past, where's my little, I can't see it very well. Okay, I'm going to go past my sample. I'm going to touch it carefully, and then I'm going to very carefully just let it fall. Okay, and as you can see, what happens there is that it gets rid of most of the bubbles in there. You want to eliminate as many bubbles as possible because bubbles are really big under the microscope. And then I'm ready to begin work, okay? So the first thing I'm going to do, make sure you can see my microscope well here, is I'm going to take my coarse adjustment knob and I'm going to rotate my stage as far down as it will go. And then I will rotate my nose piece to find the smallest, lowest power objective lens, which in this case is 4 times magnification. I'm going to lock it into place facing down. Then I'm going to take my sample slide and put it over the aperture, the hole on the stage, so that it's somewhat centered on what I want to look at. And then I can turn on my microscope, look through my eyepiece. Let's see if I can do this here. And I've taken off my goggles now just a bit so that I can see through the microscope, all right? And then I'm going to start working my coarse, the big knob, my coarse adjustment knob, up until I get something in focus. And then once I have something in focus, I'm going to position my slide so that I have something in the center of my field of view that I want to look at. Okay, so I'm looking to see good colored cells, and making sure I can see nuclei, that kind of a thing. Okay, so I've got something in the center of my field of view. So at this point, if I want to, I can probably lock down with my stage clips my sample, but I don't have to necessarily because I might need to adjust again on my next highest power. Now, to move to the next highest power, you're going to rotate the nose piece to the next biggest lens, objective lens in size, okay? You're not going to skip. You're going to go from 4. If you can see, this is my next biggest one because this is the biggest one. Does everyone see that? This is the biggest one. So I'm going to rotate to the next biggest one, which is my 10 times, lock it into place. Then at this point, I'm only going to use this little tiny fine adjustment knob to do my focusing. So I'm going to look, because I should be close to in focus, and I am. And I'm just going to do some fine tuning and get my slide in focus. And then I'm ready to go to my next highest power. So I can rotate, and you're going to be drawing all of these, and I'm going to have pictures of them for you. So I'm going to go to my next highest power. Again, locking it into place. And if at any point you cannot move that high power into position, it means you're not going to be able to use it, because you have to be able to lock it into that position at this length to the stage in order for you to get it into focus. So if you can't move it there, you're not going to be able to get it into focus because you're assuming that you're in focus here, and then you're going to be close to in focus when you rotate it. So now that it's in position, again, only the fine adjustment knob, again, don't touch the coarse objective lens after you leave low power. Okay, and do some fine adjustments. And again, if you feel like you need to move your slide just a little bit, you can do so. It doesn't take a lot of adjustment. Do your focusing, and you are good to go. And that's basically it. And then to break down your microscope, you're going to take off your slide. You're going to clean it. You're going to move your stage all the way back down and return. So you're going to go like this, remove it all the way back down. You're going to return it to low power objective lens. You can unplug it, turn off your power, I should say, first. Where's my little switch? There it is. Okay, turn off your power, unplug it, recoil it back up again. And there's different ways, there's different methods of coiling. So sometimes this is the easiest for some people, although you can see sometimes it pokes out. So you kind of have to find a way of tucking it properly. Take your plastic bag for covering and keeping dust off of it, cover it up, and you are all done. Because I know several of you at some point or another will ask me about using the 100 times objective lens, I need to explain to you why we cannot. Okay, the microscopes that we use, almost all of them have a special oil immersion lens for use primarily with bacteria. And this oil immersion lens requires that you use a special oil that actually meets up with the slide itself right here. You put it on top, and then the lens, I don't know if you can see this, but the lens right here also touches that oil to help with the magnification. It sort of interacts all together with the light source to create a more magnified image. All right, we will not be using this for a couple of reasons. One, it's really messy, and you have to be prepared to properly clean between each time you use it. Two, the other reason is because we don't really need it. Okay, everything that we view under the microscope can be viewed really easily at 400 times magnification, which is the 40 objective lens and then a 10 times eyepiece. All right. The only things that it would be really useful for are bacteria, but you can actually see bacteria at 400 times magnification. They're just going to be smaller, which is fine because, you know, most bacteria are really not that exciting to look at anyway. They're just a few different shapes and that's it. So it's not necessary. It's a little messy, requires extra work cleaning, and so we're just not doing it. I just wanted to explain to you that whole process. Oh yeah, I just realized something that you can actually see right here almost the oh, I'm a different color. I don't know if I can get the right color. The oil immersion, you can see how everything is together. You know, the lens is touching the oil, is touching the sample. All right, anyway, that's it for that.